Today on the Leukopak Lady, I am discussing the consequences of inconsistent leukopaks with a focus on overcollection and contaminants. First of all, collecting from a donor for too long has consequences. This practice increases the chance that the donor will experience the uncomfortable side effects of the anticoagulant. In this case, the donor may ask to end the collection early and likely won't return for the next collection when you need them. Overcollecting a leukopak can also have the unintended consequence of creating demand for higher yield leukopaks. And I see this as a problem overall because it will reduce the donor pool and will affect the ability of developers to get these extra large leukopaks in the long run. And this is because not every donor can sustain a long collection to create high yield leukopaks. And those who are asked to do so are likely to experience donor fatigue, and this is not good stewardship of the donor pool. However, what I see as the most significant consequence of overcollecting a leukopak donor is yielding more RBCs, platelets, and granulocytes in the product. These contaminants can negatively affect the viability, identification, and function of PBMCs in the leukopak. Let's walk through some of these effects. First of all, contact with contaminating RBCs can suppress T-cell proliferation and IL-2 production, which occurs with both intact and lysed RBCs. In addition, lysed RBCs can affect PBMC viability. An RBC lysis occurs during the handling and transport of fresh leukopaks and the thaw of frozen leukopaks. The presence of excess granulocyte contamination can also have a negative effect on PBMCs, especially T cells. Granulocytes can alter the characteristics of T cells during flow cytometry testing. They can also block T cell stimulation and suppress T cell proliferation and cytokine synthesis. Granulocytes in frozen leukopaks lyse upon thaw, releasing enzymes that damage the membranes of surrounding PBMCs and results in lower viability. Platelet contamination is difficult to avoid during leukopak collection, but it is crucial to minimize their numbers in the final product. Aggregated platelets bind to leukocytes and interfere with antibody binding for flow cytometry analysis, cell isolation, and activation steps of manufacturing, and also impacts overall cellular function. Platelet aggregation can also interfere with cryopreservation and thawing of leukopaks. References for this information can be found in my editorial articles for cellandgene.com, and I'll link those articles in the comments. So over the next 2 weeks, I'm going to talk in more detail about the donor factors that may influence the quality of leukopaks and thus impact manufacturing and therapy success.